Okay, hey you guys. So we did a lab today in chemistry, and I'm going to do this lab hopefully pretty quickly today with you guys so you can kind of see what went on. We've been talking about chemical equilibrium, which basically just means that whenever you have a reaction that can go in both the forward direction and the reverse direction simultaneously. You can have products being formed and then breaking back down, and you just have this constant flow going back and forth between reactants and products. Now, there's a principle called the Chatelier's principle that says that if you cause any kind of stress to the reaction, you can, the system itself, the reaction will try to shift in the direction to relieve the stress, to relieve the change, okay? So the reaction that we were talking about on Tuesday during the pre-lab, if you watch that video, was that we were going to start out with some CoCl2. This is cobalt 2 chloride. Okay, and we're going to take this solution, and this right now is in the reactant state. Okay, so you've got CoCl2, and it's got some chloride ions, just separate chloride ions floating around, right? And it's in the pink solution right now. It's in a state of equilibrium. Okay, but we're going to cause a change. We're going to stress the system. So I'm going to take some hydrochloric acid, some very concentrated hydrochloric acid, and I'm going to start to add it to the system. And when you do that, I don't know if you can see that, I'm just going to start to change. Okay, so right now the system is trying to relieve that stress, okay? Because right now, when you add in more chloride ions from that hydrochloric acid, because hydrochloric acid, when it gets into solution, it separates, it dissociates into H's and Cl's. And so you end up with extra chloride ions. And so you got too many. So it's going to shift to the right side. It shifts to the blue side, or it shifts to the right of the reaction. Okay. All right. So how do I get it to go backwards? Well, if I want to go back to pink, I have to think about what products are there, okay? And so if you're thinking about that, I was looking for my sheet to see if I had it out here. If you go back and you look at the sheet, there are water molecules on that product side, okay? So if I add more water molecules to that, I'm going to have too many water molecules in there. So the system, according to Le Chatelier's principle, should shift back to the left. So I've got too many water molecules in there because there's water molecules in there as a product. So I'm just going to add in, let me grab a pipette extra. I'm going to take this little pipette here full of water, and I'm just going to start to add that in. I'm going to put in more water molecules, and when I do that, you can see that it's starting to shift back to pink. Okay, so it's going to shift back to pink. Okay, I'm actually going to take my stirring rod, if I can find one here. Make sure it's really good and cleaned off. Just going to start to stir that up. Got all that water in there. It's pretty much shifting back to pink. You can see that. It's just back in the pink direction. Okay. So I'm going to save this one for just a little bit, and we'll come back to that one here in just a minute. Okay. So that's a couple of the reactions that we did today. Again, we went from a pink solution, we added hydrochloric acid, it shifted to the right because there are too many chloride ions. So it shifts to equalize the system, shifts to the blue side. Well, once it was blue, there were too many water molecules. So I wanted to add more water molecules. So then there were too many. So it shifts back to the left, to the pink side, because it begins to use up those water molecules. Here, we're going to start again. So this is brand new CoCl2 solution. With this one, I want to add in some acetone. Now, if you go back and you do look at the pre-lab from Tuesday, the pre-lab said that acetone acts as a really good water remover. You can add acetone to lab equipment. You can add acetone to lab equipment, and it will actually remove water from the system. So that's what I'm going to do. I'm going to add in this acetone, maybe. Very carefully. I don't know if you can see that, but the acetone is pulling water out of the bottom part. It's pulling that water out, okay? And it's removing the water. So if you're taking water out of the product side, that reaction, as you take water molecules out, the reaction's like, oh, wait, we need more. So it's going to start to shift the reaction to the right side, to the blue side, because you're taking water out. So the system has to replace it. It's trying to replenish what's being lost. Okay. All right. And then finally, or almost finally, we've got one more. Okay. So if you have this pink solution, this is COCl2 again, and we're going to add in some silver nitrate, AgNO3. Now, if you go back and you read the pre-lab, from the pre-lab, it said that AgNO3 would actually go in, and AgNO3 is going to pull out chloride ions. Okay, so it starts to pull out chloride ions like this. And when it does, you've got precipitate that's going to form, okay? So you got chloride ions that are getting pulled out. They're getting attached to the Ag, so you have precipitate that forms, okay? And I don't know if you can see that, but the color of that milky white stuff at the top, it's pink, okay? Because you're removing chlorides. You're pulling them out. So as you pull out the chlorides, the system shifts back to the left. It shifts to the pink side because it's trying to replace all those little chlorides that are getting pulled out to make the white stuff. Okay, and you can see all that white precipitate there at the bottom. Okay, and so you're pulling all that chloride out. So it shifts back to the left to the pink side. Okay, now finally, last one. Okay, our last two. Remember that reaction that we did a while ago with, oops, there was our acid, and it turned blue, and then we added water, it turned back to pink. Now we want to see if we can make it turn blue again. So we're wanting it to go to the back to the blue side. Normally, the pink reaction is endothermic, which means that energy is needed in the system in order to make it run. So energy would be added as a reactant. Okay, if you give it even more energy, for instance, if you put it in a hot water bath like this, what should happen is eventually, I don't know if you can see that, but eventually it should start to turn blue. It goes from pink to blue because the system is absorbing all that energy. It's pulling in all that energy. And so because it's got extra energy, it's going to start to actually shift to the, that's hot. It's going to start to shift back to the right side because it causes it to move in the forward direction because you're giving it extra energy. You're putting extra energy on that reactant side, so it shoves it to the right. Okay, it's going to cause it to make more product, which is the blue part. Okay, now how do we get it to go back? How would we get it to go back to being pink? If the hot water makes it go blue, cold water must make it go pink, right? I've got helpers now. All right. So I'm going to take it, I'm going to put it in some cold water, and hopefully we'll give that just a second to sit there. So now the blue side was very exothermic, okay? So what we want to do is we want to take some of that heat out. So if you're removing that heat, if you're taking it out, hopefully here in a minute, it should start to go back to pink. I don't know if you guys can see that. But it's starting to lose its blue color. Can you see it though?
Yeah.
You guys want to see it go back to blue?
Yeah.
Okay. But there you have it. We're going back and forth between blue and pink. And again, temperature, concentration, and pressure, those are all ways that you can change a system. Just like here, we're changing the temperature, so it changes the system. And the system is trying to correct itself. That's according to Le Chatelier's principle. It will shift to the right or the left, depending on what it's trying to do in the reaction. Okay.
know.
All right, bye.
Ha! I was in it more than you.
Well, okay, I'm fine with that. That thing that Mr. Butler got Maddie that made me was good.